Happy Super Science Saturday, everyone!
Morning!
Welcome to Super Science Saturday with Mark and Ali here at Explorium.
On a frosty January morning.
Frosty January morning.
Very chilly.
Yeah, mucho de-icer this morning.
Oh yeah, I went for the old water technique and chucked water in the car and sat in. I was like, I'm ready to go. And then there was still just like such a thick layer of ice in the windscreen. I had to go and get more water.
Coldest night of the year last night.
It felt it.
Yeah, it got down to -8 in some parts of the Midlands. -8. That's really cold.
Like, I just had a shiver thinking about how cold -8 is.
If there's anyone watching from the Midlands, let us know how cold you are.
Are your fingers okay? Are they just like icicles?
They're all just frozen.
They can't type. Their hands are completely frozen.
Good morning to everyone. When you join us, please say hello in the comments. We'd love to give you a shout out. Good morning, Sophia. Good morning, Ursula. Sophia, we did like the snow. Yeah, there was a nice kind of dusting of snow.
I love the snow. It very much melted very quickly. It was kind of, if you slept in too much, you were going to miss it.
You were going to miss it.
You were going to miss it. Yeah, it was nice to wake up and to see it. Yeah. I went for a run the other day, and there was still like...
slip.
You know, I did slip recently.
Recently?
So, do you remember, I was actually going to tell this story last week, and I was like, no, it's too embarrassing, but I'm going to tell it anyway. You know, last week we were talking about slipping and about friction.
Yeah.
And I was saying I had actually been out for a run, and it was like a really icy morning, and I didn't slip for the entire time I was out for a run. Yeah. And then I went to Lidl.
And
I slipped on the travelator in Lidl.
Slipped a little. Oh, on the travelator! Not even outside.
Yeah, not even outside the travelator was wet. And my feet just went down from under me, and I had 2 tins of soup and
Well, you proper fell like?
Oh, yeah. I have a bruised elbow. Had a bruised hand for a while, but I just thought it was gas. Like, I was outside running in the ice and the snow and didn't fall a lot, and then slipped on the travelator a little.
Good lord. Good morning, Declan. Good morning, Aoife. Good morning, Evie Bike Dude. Welcome. Oh, good morning, Michael. Mother says hello.
Dad, do you not say hello? It was just Mom that says hello.
We did love the snow, Sophia. Did you get much snow where you were? Let us know how much snow you got where you guys are. A little bit of dusting here, not much.
Lidl has a travelator. It's when you're going in from the underground car park into Lidl in Little Stillorgan.
Oh, Sophia made a snowman.
Nice.
Cool. Oh, that's pretty cool.
Oh, there's a few votes here for electric. Evie Bike Dude and Declan, you guys should talk electric cars.
Yeah, Declan's already had a dig at you for already. It's like Saturday morning, dig right in there.
Right in the kidneys.
Right, like, ow. Oh, I can't. Remember that really famous YouTube video though? It's brilliant, where the 2 runners are. Do you know this?
No.
You should know it already. No. It's like, there's a big snow, maybe somewhere in Canada or something like that, and there's 2 joggers out during a very heavy snow, and they're being interviewed by a reporter saying, is it not slippy when you're out jogging?
I do know this.
And the lady's like, no, it's actually really great, it's just so soft under your feet. And the reporter's like, okay, cool, thanks for talking to us. And they're like, great, and they jog off, and she skulls herself.
But you actually, do you know what I saw?
Proper, like, looked sore.
Yesterday was the anniversary of your man who slipped on the ice on RT News. Yeah, I think it's like 8 years since he slipped on the ice on RT News. Since yesterday.
No, they checked up with that fella. He's not doing so good.
He's still bruised.
He's kind of everything. He thinks he's going to slip all the time now.
He walks like real
walking around his house. He's got those suction cups on his feet. That's how they call him, suction cup Johnny. That's
8 years. Thank you for it is 8 years.
Okay, wow. Yeah. I love that it's. You're a man. 8 years since, you're a man. I know.
What you're talking about. It's brilliant.
What an absolute legend. Like, he should be president at this stage.
Can we get him on the show?
Get him on the show. Yeah, get him on the show. I would love if he just continually slips everywhere. He should have made that his character.
We'll have our people call his people.
Yeah.
We'll get him on the show.
Yeah, we'll just shout,
like an ice rink back here and just send him on his way.
Let us know if any of you guys checked out some of our shows at the BT Young Scientist. I really enjoyed it. It was virtual this year. A little bit different. It's very hard to recreate that real buzz with like thousands of students.
Yeah, very different. But you know, you got to watch it from the comfort of your warm bed, which is pretty nice.
Warm bed.
Yeah. It's too cold to get out of bed these days.
But let us know if you caught any of the shows or any of the other shows, or seen any projects you really enjoyed.
Yeah, so a computer science project.
Won it.
Which is really interesting.
And really fantastic, because it was something that we did a few years ago in the Science Gallery. They showed a video of Barack Obama speaking, announcing to the nation, and he didn't say any of those things at all. It was computer generated. And it looked like Obama talking, and that's terrifying.
That's terrifying how much you can manipulate people's words and like, because they can kind of analyze people's voices and then make it sound like a completely, because you know, it's not like when you like chop bits of sentences that people have said together. Like it's pretty obvious when they do that.
The nation, you really like it to have cornflakes in the morning.
So there's videos on YouTube where they have like
the lip stuff. Yeah.
Saying like "call me maybe" and stuff. Like putting random bits of their speech and stuff together.
They're great, but terrifying. And what it explored was the different methods through the years of deceiving people. So like it would have started with Photoshop, back in like the 40s, where people were like, you can't manipulate photos. If it's in the photo, it happens.
Yeah, it has to be real.
There was one great example where there was a protest, and they wanted to amplify the amount of people that were there. So they painted them in. They painted a huge crowd instead of like the 12 people that showed up for it. But people believe it because they're like, it's in the photo. It can't be. So the video age now is our age of deception. So deepfakes it's called. Really cool.
Yeah.
Congratulations.
Oh, and Aoife says there was a deepfake of the British Queen aired over Christmas as well.
Yeah, unbelievable. They're extremely difficult to tell.
Is our show real?
Yes, we're at home right now in bed, like. And wait, that wouldn't make sense. We're just, what?
It's not. I don't know. But there's some way that AI can do it. I don't know. There's some way that they show with deepfake as well. I don't know.
Deepfake AI, extremely scary stuff. Absolutely.
Yeah.
But there you go. New technology to be able to distinguish what a deepfake is, what a fake video would be. Very important.
These are teenagers doing these projects. Like it's mental. I couldn't even begin to get my head around how to do things like this.
Excellent ones that I was fascinated with as a kid as well. The Loch Ness Monster pics. They were some of the earliest fakes, and let's not get into the Turin shroud.
That's a bit controversial.
We'll skip back. Sophia just said, your show is real.
Thank you, Sophia.
Is that like an actual statement where like, no, it is real, or you're like, it's like a compliment like, your show is real, dude. Your show is real.
I'm going to take it as both.
Yeah. I like that. I'm going to use that. You know, it's like, your show is dope. Now just like, it's real. Show's real, man. You're like, that's the new compliment.
You're a dope. Had to do it.
Wow. Wow.
I am having a bit of an existential crisis.
Yeah.
It's very early in the morning for all of this, isn't it?
It really is. We're going to start off with the solution to last week's challenge, because it's the basis on which we formed our lives.
Yes,
the show. So we challenged you last week to come up with different ways of dropping a mug so it wouldn't smash. Now, lots of ways you can do this. You could get really simple with it, put a cushion underneath it, you catch it like I did, but we were pushing you to come up with some different types of solutions. So one of the solutions, really cool. It revealed some absolutely awesome physics that seems almost counterintuitive.
This blew my mind.
Yeah, it's really, really cool. And I remember the first time I was showed it back with the Institute of Physics. Michael, who might be watching as well, showed me this, and I was like, oh my Lord, that's phenomenal. Yeah, mind blown. So I've been obsessed with it ever since. But basically what we did, and we want you to try this at home too, because you can. It's simple.
So simple.
What we decided to do was we tied a spoon to the mug with a string. That's it.
Yep.
And watch what happens. Okay, so what you would do is...
Yeah, it's not as simple as it's just tied to a string.
No.
And you drop the string.
So this is a spoon here, and we have the mug. So I'm literally just going to let go of the spoon.
And drop the mug.
And you would think that the mug will crash to the table and smash, but look at that.
Brilliant. Do it again.
I gotta do it again. Sometimes it flips back on itself. Okay, you're about to drop it. Spoon here, and look at that. Just before smashing on the table as well.
So if you lower your hand there, you can get in the shot. You can see the spoon wrapped around Mark's finger.
It just wraps around, so you can, let's do it over so it's just a big drop right back. So you have the spoon and you let go. Wow! As you're about to see, there are lots of ways you can try this, and do it preferably with someone else's cutlery. Floor's laughing like crazy. And wait till you see how much we push this to the max.
That's why I'm so blown, because it works so well.
And that's never ever happened. We literally dropped that mug from, what is the height?
I was actually going to ask you this.
10, 15 feet?
Easily 15 feet, I'd say.
And to the absolute max.
I can't believe it.
I know. Well, we're going to show you how you can do it, and that's a sign to be
Anyone for a cup of tea?
quite careful and have either a backup mug or use someone else's mug. Well, we can't wait to show you how to do this at home so you can see.
We're going to show you with some less fragile.
This is why we've
bits
chosen
first.
some things that doesn't matter if they fall and smash.
No. So
very
we've
simple.
taken the same principle here, and
We've prepared many earlier.
We've got some washers here that you can get in like the hardware store. So we got 14 washers on
Yeah.
one end of the string and one washer on the other end. And
Yeah.
that ratio is very, very important. So
Very
14 to 1. So we'll do the same thing again. So I'm going to let go of the single washer.
And there you go.
Wraps around the finger like that.
Wraps around the finger.
And doesn't fall. So we're going to show you how to make your own one of them.
Very,
so
very simple.
You're going to get a piece of string or wool, and this is like knitting wool. And it's about, what we said, about 60 centimeters long. So
Well, yeah, and you can experiment with this. Doesn't have to be absolutely exact. Like,
yeah, we went with like 2 long rulers worth. So then you're going to get whatever object you want. So what we were saying there is like it's important. The ratio of weight is important. So with these, it's kind of handy because you can do 14 of the object versus
very,
one of
very
the
good.
object. Otherwise, you can weigh your object.
And we did that as well to try and make sure the ratio was right. And we found as we kind of experiment with other things, the ratio is
There's
kind
some
of
wiggle room.
There's wiggle
some
room.
wiggle
So
room
it's kind
to
of like
it,
you test it and put cushions underneath your objects in case they hit the ground.
Didn't do that there though,
No,
did you?
no.
So I've tied one washer to one end of the string, and I'm gonna tie 14 to the other. So 1, 2,
this.
3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay?
Yeah.
And I got some spares. So with some things, what you might notice is 14 works. Other times, maybe 15 works better. It can depend on the type of string that you have.
Yes.
Because we noticed some of them, there's a bit more friction in them than others. Some
we got
strings
some-
are slippery.
Because that's exactly what happens is it's friction. When it starts wrapping around, friction keeps that on your finger and it prevents it from falling down. You've basically made a pendulum. That's exactly what this is. So this is your pendulum. You have a weight attached to a string and the finger part is going to act as your pivot. And as you let go, the pendulum falls under gravity and wraps around your finger like that. Now, you might see pendulums on things like the old grandfather clocks. They have the pendulums that swing down the bottom. But what's really cool about this is obviously when you drop your pendulum, the little stack at the end falls under gravity as well. And as that falls, it makes the pendulum smaller. The distance from the washer to your finger gets very small very quick, and that causes its velocity to speed up, and it causes it to shoot all the way around your finger,
and over.
and then friction keeps it in place.
So
Very, very cool.
Tie your 14 washes to one end, single wash to the other end, and kind of keep it parallel to the ground.
Yeah,
So you want to keep this string as flat as possible, and then you just let
Let it
go.
go.
Like that.
Yeah.
And it wraps around your finger.
Yeah.
So like we said, we tried it with some washers, and we tried it with some
We
nuts
started
and
trying to
stuff.
scale it up a little bit as well.
So a little bit more weight. Again, 14 to 1 was the ratio we went with here, and it works exactly the
Perfectly
same way.
well.
So then we kind of want to get a bit more creative with it.
Absolutely, because if you discover a relationship, then if it works for something light, then it can work with that same ratio for something a little bit heavier. So we were thinking, we're like, okay, let's push this a little bit.
Yeah.
What things can we find around here that have that similar ratio that we can repeat? And then we're like, well, we need a greater height to do this from as well.
A little bit more risk.
Yeah, a little bit more risk, which we did. So we decided to do it with the mug, and
Mug and spoon.
it was very, very successful. So we decided to increase the height and increase the risks, and we did it from a height of like
About 15 feet, I'd say.
really, really high. Massive string, big pivot, very, very cool.
What we did was, so we had the washers, then we went for the smaller nuts, so then we got these larger ones, which have a lot more weight to them. So we dropped down, so 14 on one side, and then a single one on the other end of the string. We did that. We dropped the mug and the spoon.
Dropped the mug and the spoon, then we're like, what else we got?
What else can we
Sophia's
do?
a tire. That would have been really cool.
We decided that we'd bring our friend Rachel, the Mars rover here,
Let's bring her up, see how she...
and see how she would fare the drop.
Yeah.
And we weighed her, and she was about 1.8 kilos was what we came up with. So we were looking for something that was roughly in the 1 to 14 ratio of weight. And what we discovered is the controllers
Amazing.
that we use to control the Mars rovers were pretty close
Similar in that ratio,
to within that 1:40 ratio,
So we
which I
decided
thought
to
was
test
quite
it.
nice because rover and its controller,
Yeah.
we had mug and spoon, which
Yeah,
are related
very
to one
relatable.
another. And yeah, we took it to the extreme.
We took it to the stream. We're going to show you a video of how we got on. It was absolutely awesome.
Yeah.
We had so much fun.
You can
and
see how excited we got every time that it worked.
And this is something like, look around your home, see things that might have that similar ratio, and just test it out. We tested out some crazy things, and we showed them.
Yeah, let's show them. Let's show them.
It was super fun. So this is the height we decided to do it from. Check that out. That was the kind of larger nuts. Yeah.
So we've just tied some streamers around it.
Then we tried
There's the mug.
There's the mug.
We put some fabric underneath it just for the test run.
Then no fabric.
And then
Check
let
it
it
out.
go.
Look at this. Ooh, ah!
And no break!
And it wraps. Yeah.
And yet it broke here.
And
Such excitement.
And you can see the pendulum wrapping around the pivot on top. And this is Rachel the Rover.
Rachel
Look
the
at that.
Rover.
That was close.
That was close.
That was so close.
So we did
Very
swap
cool.
out the type of string that we used when we went from the mug to the rover, because obviously the rover was that bit heavier. So we thought that the wool would be able to handle that much weight. So we went for a slightly stronger string as we went along.
Oh, this is cool. Look at this, like.
We put a lot of faith in science.
Yeah,
that day.
absolutely. Like, that was absolutely awesome. Really cool to experiment with different things and see what works. And again, you're making your own pendulum, and the awesome physics at play, because you think it would just fall, hit the ground, and smash.
You would think that would happen.
But if you do it correctly, it doesn't.
It works fine, yeah. So, like we're saying, start out with something simple with 14 versus 1 of the same object before you start getting into the whole idea of weights and having to divide. Dividing's tricky. So, start off simple with something where you've multiple of one thing, and then scale up and see where you can go from there. And if you have any ideas of things you would like us to drop, let us know.
Good morning, Alistair. How are you? Good to have you back. Eve, I think every time Aoife says something, I think it's a joke now. That mug that survived so much to be
cruelly sacrificed by Mark. Again, I speak Aoife. Cian wants us to drop a mixtape.
Drop a mixtape.
Drop a beat.
Yeah, we're Super Science Saturday mixtape.
A beetroot. Drop a beat.
We tried to rap on this show before, and I tried to drop a beat, and you wouldn't rap.
I can't rap. But can we try it? Can we drop a beetroot?
We can have nice, clean.
Can we drop a beetroot? So it's drop a beat.
You could,
That's funny. That's kind of funny.
Yeah,
it's kind of funny, isn't it?
Yeah, really good. Yeah.
So if there's any, we've kept our line in place for our 15-foot-ish. We need to measure what that is.
Yeah.
Our large drop.
Yeah.
So if you can think of any other things that you would like us to drop and show in a future show, do let us know.
Future show. Yeah, that'd be really cool.
Or on social media.
Yeah, if you come across things in your own home, or things that you find work.
And you don't quite want to risk it yourself.
Yeah, let us know. We'll test it for you. We'll be those people.
We'll do that for you.
We'll be those people. Now, last week we did, obviously that involved a lot of awesome physics.
Yes.
Last week we celebrated the birthday of a very famous person in physics, Sir Isaac Newton, the laws of motion.
His birthday was on the 4th?
4th of January.
Yes.
Yeah, so...
Which was what day? Tuesday?
Monday. Yeah. There you go. So this week we decided that last week was kind of Newton week.
Yeah.
And this week will be non-Newton week.
Yeah.
And there's an awesome thing that we do to explore non-Newtonian things.
Yes.
So we're going to make this with you today. It's one of our favorite things to make. We've been looking forward to it for quite a while.
Yes. We were like, this is the time to bring it out. Oh, that was heavy.
Sophie says, what is a mummy's favorite music?
Rap.
Graham,
why are you shouting?
She's just shouting at you.
Ali! What have I done? What have I done to deserve this? I'm so on edge now. I'm like, what's going to be said next?
Evie Bike Dudes topped your just dropping a beat. If you dropped a sugar beat, then you could drop some sweet beats.
Nice.
Some sweet beats.
Nice.
So to make what is called Oobleck. It's a non-Newtonian fluid, and we'll explain what that is. The ingredients are very, very simple. Basically, cornstarch and water, or corn flour.
Corn flour, which you can get super. Oh, Graham wants you to drop Ali.
I thought he was like, drop hello. Drop hello.
Drop me. No.
That would be brilliant. Imagine. We'll take it to the max. Like, just have you hanging out.
It could end very badly.
Yeah, still learn things.
Still learn things. Okay, so you can get corn flour really, really cheap in any supermarket.
Very cheap.
So we just cut up in the bag there.
Yeah.
Pour the whole thing in.
Yeah, go for it. Like, basically the ratio is roughly 2 parts water to 1 part corn flour. So that's roughly the ratio that you're gonna make in your mixture. So let's just mill it all in. We got plenty of water that we can.
Yeah.
Now, this gets very messy. So definitely something to have some blue roll.
Aoife, where's the blue roll?
I got it. Close at hand. And you can use gloves as well. As there are mucho electronics to control around, we'll go for gloves.
Okay.
Otherwise, my laptop would be destroyed.
They're covered in Oobleck.
Destroyed.
So Oobleck was actually, the name Oobleck comes from a Dr. Seuss book.
Yeah.
Bartholomew
and the Oobleck, yeah.
From what, like, it's written in like the 1950s or something, I think.
Ooh.
Yeah.
What was that? It was written in the 1950s or something. Yeah.
I haven't read it, but I believe that's where the phrase Oobleck comes from.
Very Harry Enfield head near there. Yeah.
We love Harry Enfield in our house.
Yeah, big fan.
Aoife, since it's edible, is it a non-newtonian fluid?
Don't eat it. No,
Don't eat your science.
Don't eat your science.
Don't eat your science. Okay, so we're gonna.
Basically, we're gonna pour water in, and you get your hands in. You can use a spoon as well, especially at the start, just to mix it around. And you'll start to see as you're mixing it around, and it'll take a little while. It'll start to form this strange kind of consistency, and sometimes it'll start to feel a bit solid. So you can keep pouring some more water in. So we'll get a little bit more in, like that, and you're gonna get it mixed around. Now you're gonna mix it, kind of adding in more water, little bits until it forms like the consistency of honey. Now I think I'm gonna get my hands in at this stage, move things around, and we can get some. Ooh, nice. I think let's throw some food coloring in this.
Classic.
So it has type of beige type of color at the moment, but we want to make sure it has a. Oh, nice. Oh, nice.
That's a good pink.
Nice.
Oh yeah, Aoife says if you put some cling film over a speaker and put the Oobleck on the cling film, it'll dance.
We're gonna do that, yeah. Oobleck monster. So let's throw get some more cornstarch in here a little bit. Now I'm gonna get my hands in at this point and
put the spoon
try
on
and
the
get
bag
that
so we don't mess the
consistency
table.
of it. Okay, so get some more in. And I'll keep mixing it about. Now, that's super. I'll keep mixing. Now, what you'll notice that Newtonian things are things that you they act as you expect them to act in this kind of world.
They follow the rules.
Yeah, they follow the rules.
Yeah.
So with a non-Newtonian liquid, let's get some more cornstarch in there. With a non-Newtonian liquid, it doesn't respond to temperature. So usually when you heat a solid up, it will start to melt.
Yeah.
So that's kind of how Newtonian liquids react.
Yeah, like water. Water is a Newtonian liquid. It does what you expect it to do.
Yeah. But a non-Newtonian fluid doesn't follow those Newtonian rules, and Oobleck responds to pressure instead of temperature. Now we're almost there. I can feel the kind of gooiness. Stick a little bit more in. There we go. Because you'll start to feel that kind of consistency, kind of like honey. And you're gonna do some smashing?
Yeah, I'll do some smashing.
Yeah, go and do some smashing.
Well, I'm not gonna smash a mug like somebody.
I did say that it'd be a smashing show.
Yeah, true.
Just delivering. Okay.
Got some gloves on.
Okay.
You don't have to use gloves. Like obviously it's perfectly safe, but it's messy.
Again, it's cornstarch and water. Like.
Although Declan makes a very good point. We don't normally try and keep things clean. We're normally all about the mess.
That's not our style. So I think we're at a pretty decent consistency now. You'll see it's quite gloopy. I would even put in a tiny bit more cornstarch, yeah. Because you want to just judge. You don't want it too kind of liquidy, and just kind of mix it around.
Morning, Eagle Eye. How are you?
What's up, Eagle Eye? Okay,
we're just making some Oobleck.
We're just making some Oobleck. Okay. Oh, you can even starts to get clumpy as well. It's pretty fun. It's pretty cool. Like it's a good kind of.
I like the color.
Yeah, the color. It's really nice. It does look appetizing, but again, don't eat your science.
Aoife says you can eat the science once. No, Aoife.
Okay, so let's stick in a bit more cornstarch.
Okay.
There we go. Okay, we'll get it going around.
Oh.
Yeah.
It's getting chunky.
It's getting chunky. So Oobleck responds to pressure. So if the mixture receives an impact, that kind of turns it into a solid. So it goes from liquid to solid. So it's a liquid that acts like a solid. Now it's really fun. because your hands can get stuck in there as well.
It's like quicksand.
It's yeah.
And quicksand, honestly, is something that from TV shows that I watched as a child, I thought quicksand was going to be a much larger problem in my life.
What?
You know, in TV shows, they always encounter quicksand. It's like, oh no, you got to rescue
It
the
does
person
look
from the
terribly
quicksand.
dangerous,
But like, when have you ever come across quicksand in your life?
Yeah.
I think I should be
Sometimes you're on the beach and you're just like,
By this, I should be more concerned about coming across Oobleck than quicksand.
Oh,
because
yeah.
I've already come in contact with Oobleck more.
in your life.
Yeah.
Like, where was the Scooby-Doo show about Oobleck?
Well, there probably was one.
There probably was one. Okay, get your fingers in there and we'll see. We'll now let me.
Oh,
it's so messy. Okay, I might throw some more cornstarch in.
Yeah.
We'll see.
it's pretty gloopy, all right.
It's pretty gloopy.
Oh,
Yeah. Okay.
give it a squeeze. Oh, yeah, when you squeeze it.
Yeah. Now for this, I'm gonna take the gloves off.
Okay.
Because we
Forgo
have
the cleanliness.
we have our gloopy liquid, and I'm gonna show everyone and prove it to everyone that it is indeed a liquid. So let's get that off.
Okay.
There. Okay. Now, very clearly a liquid. You can see it moving about in the bowl.
It sloshes.
It's
It
sloshing.
swirls.
Now, if we apply a force to this and apply a pressure to it, all those cornstarch particles, which are now kind of just suspended in the water, where if you put your hand through it slowly, it feels like a liquid. But if you put some
Ooh!
force to it,
You could hear the thud of that.
there's no splashing. You would
Punch it.
ain't no splashing.
Little bit splashing.
Check it out.
That's wild.
Very cool. And you can tell it is a liquid. It receives a force.
So yeah, when you jab at it like
Yeah.
that, it's very much like a solid. But if you put your hand in and you scoop it,
Liquid.
it runs off like a liquid.
So nice and slowly through it. Even let's go all the way down into, you'll see that it is
Very much a liquid.
drippy like a liquid. But if you apply a force to it,
It's so weird.
all those cornstarch particles clump together to form a solid. Now, you can mess with the mixture as much as you want. It's very cool. It would be absolutely awesome to do a little jig on it.
Yeah.
Do a little
Because
do a little dance.
You can, if you have enough of it,
Yeah.
you theoretically can walk on it.
Oh, yeah.
As long as you apply pressure to it, it will act like a solid and you can walk. Didn't this happen on a TV show before where someone walked on custard because custard is like a non-newtonian liquid?
Absolutely,
Yeah.
So really, really cool. You can do so many things with it as well, and it's so much fun.
It's such a bizarre. It's
but
like
it's so odd,
It's
like.
like slime. It's a similar.
Yeah,
thing,
it's
but
kind of it has that kind of like
when you're
slimy,
hitting
goopy
it,
type of.
when you're hitting
quality.
it, it's like like slime. But then when you're running your fingers through it, and it's like a liquid. It's completely different.
Yeah, but
can't
super
describe
fun.
it.
No, need some blue roll.
Yeah, Sam for Dublin, same with me. You're always worried about coming across a deep pool of quicksand.
Always worried.
Hollywood made us afraid of quicksand unnecessarily.
Yeah,
Oh,
absolutely.
I'm dripping it
Now,
over.
this is really fun, and it's just water and cornstarch. You can make as much or as little of this as you want. Something that's very important though is to not throw this down the sink when you're finished with it.
No.
This is super important. That is not what you want to do.
No.
Because it will clog your drains.
It's very important to dispose of your science correctly.
Yes.
And responsibly.
What you can do is throw it in a bag and put it in the bin.
Yeah.
Best way to get rid of it, because you do not want to put that down.
Oh, Eva, that's really interesting. There's speed bumps that contain non-Newtonian fluids, so the bump is harder if you're speeding when you
That
hit
is
it.
an unbelievably cool piece of information.
What a very cool application of science.
Very, very cool.
We love a real world application of science.
Absolutely,
We love
yeah.
that on the show here.
Like, this is bit-o' crack.
Bit-o' crack.
But again, there are great applications for this as well in the real world. That's a super one by Eva. That's really cool. Speed bumps that contain non-Newtonian fluid. So the bump's harder if you hit it when you're speeding.
Very
That's
clever.
really cool. Sophia, this is not soup.
Oh, and EV
Definitely
Bike Dude
not.
uses motorcycle body armor that does the same thing. Oh,
Very cool.
really
Unbelievable
interesting.
applications of non-Newtonian fluids. Really fun. And again, something you can very simply do at home.
I tried to brush the stuff.
Not
off
your
my
jeans
jeans, I
again.
made it worse.
Oh,
I've got it here. It's okay. We'll clean it later.
We'll clean it later. Mucho. That can get messy. That can get messy.
Yeah, but fun messy. We like a bit of a fun messy science.
Now, it was a cool week for science because we had, obviously, the BT Young Scientist was on. Very, very cool.
It was also...
Very dry, isn't it?
It was, you know, we made the bird feeders last week.
Yes.
And the
bird
5th,
feeder.
which was Tuesday, was World Bird Day.
Oh,
So
perfect timing.
if you did make any of the bird feeders that we made on the show last week, do let us know. And hopefully you got them out in time for World Bird Day.
Yeah, because like extremely cold.
Very
over the last
cold.
week,
And I'm telling you,
meant to be cold.
the feeders have been hopping this week.
Hopping.
They've needed some good refills this week.
Yeah, I've heard about them as well. Word's going around on the street like, these bird feeders, great deals down there.
They're the ones to get to.
Good seed. Good seed. Now, we were searching around. There's a lot of cool science going on, and we're obviously always keeping our ears open for some science stories. And we came across one, and we're going to bring back the what is that number?
What's that?
What is that number? The number this week that leads into our science story is July 19th.
What does July 19th mean to you? Let us know in the comments what July 19th means to you.
Ali, what would have happened on July? Should we check the calendar? July 19th.
Check the calendar on my computer here.
Check the calendar.
July 19th.
July 19th. Why does that rings a bell, doesn't it?
The day the Ice Age ended.
Ice Age ended, yes, that's cool. Galway liberated from the Indians.
Marathon became Snickers.
Yeah, big day, July 19th.
It's also the day the Ted and Dougal go on their holidays.
It is, yeah. And this year, last year's July 19th turned out to be the shortest day recorded.
Yes.
Yeah.
Now, not what you expect, because obviously the shortest day of the year
is around the solstices,
is in the winter time.
Yeah.
But July 19th, right, Graham's on it. Marathon becomes Snickers. Where was it going? Oh, yeah. So typically we would say that the shortest day of the year is during the winter.
Yes, yeah.
Because
exactly.
That's, you know,
winter solstice, December 21st, around that kind of time.
We're getting the grand old stretch of the evenings now. Coming back.
Come back, thankfully.
But interestingly enough, no, not the case. July 19th.
Yeah. Recorded the shortest time. So it was actually shorter by 1.406 milliseconds.
Yes.
So that's how much it was shorter. Scientists found out that the Earth was actually spinning faster.
Yeah. So
spinning faster.
One rotation of the Earth is 1 day. Yeah.
Exactly, yeah.
But obviously if the Earth changes its speed of rotation, then theoretically the length of the day can get longer or shorter. So because the Earth is spinning faster, as scientists have noted, the day is technically getting shorter by a whopping 1.46 milliseconds.
I did feel that.
I felt it too.
July 19th, I was like, something different about this day.
And July 19th, we did a Rube Goldberg show on July 19th.
Unbelievable, yeah.
I did notice there was, blink and you miss it. Like,
it was just, I felt at the end of the day, I was like, today felt like a millisecond longer.
Yeah. So there's a good few theories that scientists have as to why this is the case. And they think it might be because of things like mountain erosion, climate change.
Ice melting.
Because if the ice melts at the ice caps, then that changes the distribution of weight around the Earth, so the ice would melt and the water will come further down the planet or further up the planet.
Now, the speed of Earth's spin is variable. It's not absolutely solid all the time, so it does vary over time, and things like that can change it. The moon's pull as well. Things like this can change the speed of Earth's rotation, but it was generally slowing. The speed of Earth's rotation was generally slowing, but they noticed that other factors actually caused it to speed up, which is pretty cool, because we're all on Earth now, and sometimes you think it's like, you don't see it spinning, you don't feel it spinning, you assume it's not spinning, but the Earth is spinning extremely fast.
Yeah.
At the
so
equator,
even if you think you haven't gotten out of bed today, you're like, I haven't done anything, I haven't moved
You've
at all.
travelled very far.
You've moved loads.
And very fast. At the equator, it moves about 1,600 kilometers an hour.
Yeah, same.
You were moving a bit more sluggishly this morning.
I have a sore knee today. Slow me down.
Your personal problems to yourself and off the show.
Slow me down a bit, you know. But no, you're moving really fast.
I think this is good. Fleur said, "Time flies when you're having fun." Watching A&M. Texas A&M.
That's cute.
We should have went to Texas A&M.
We should have gone to what?
Is university in the States.
Oh, sorry.
And I suppose if you don't watch really NFL.
I've never been to the States. Oh, NFL, go Pack Go.
What was that?
Go Pack Go. The Packers, the Green Bay Packers. They're a sports team.
Yeah, maybe we can have Super Science Saturday can go on tour.
Love that. When we're allowed to travel again.
Yes, of course. We'll get a sponsor. We'll head to the States. And we'll just do a scientific tour of the States. Yeah, we'll put it on the calendar. July 19th.
July 19th. Let's not get ahead of ourselves. July 19th.
We don't get ahead of ourselves.
2023.
Yes, that's true. Now, speaking of science stories...
Graham, go. Graham gets it.
Weirdo. We have a guest coming on as well. We have the Tomfoolery of Professor Rob. I know he's up to some...
here somewhere.
Yeah, some... it's pretty chilly outside. Yeah, some Frisian tricks. So let's jump over to the Tomfoolery of Professor Rob.
Welcome back to the Tomfoolery of Professor Rob. Agricultural Month, Week 2. Now, while last week we discussed our little piggy friends, today we're focusing on a bigger customer. Yes, boys and girls, while it's cold outside, it's Frisian in here. Of course, I'm talking about our bovine brothers, the cow. Now, in Ireland, we are very familiar with cows. All you have to do is drive down a country road and you're often going to be blocked by a herd moving from one position to another. Now, this is because cows are a massive part of the agricultural industry. Cows come in all shapes and sizes. There are in fact 800 different breeds of cows. As I've said, Maggie here is a Frisian. My personal favourite is the Belgian Blue. Look that up, and hey, in the comments type in what your favourite breed of cow is. Could either be a Jersey Black or a Highland, you know, the hairy ones. They're kind of cute. Not great, but cute. Anyway, looking closer at the cow, we can see that it has almost 35 teeth, which are very strong. It has a very powerful jaw here. And around the mouth as well, and this is hard to believe, is the producer of some of the most potent methane gas. The agricultural industry is responsible for almost 80% of all methane outputs leading to climate change. Mad. You don't see people flying these bad boys around the way they'd fly an airplane around, yet who gets the blame? Poor old Maggie here. Had a good life and now teaches kids about how cows can always face north. That's why Maggie equals magnets. Well, thanks for tuning in to week 2 of Ag Month. Tune in next month, or next... Oh, I've just ruined this. Start it again.
Oh, bit of technical difficulties with Rob.
I think you would check back in with him.
Yeah, he's a big professional. Like, so he's very professional.
He wanted to correct.
No, it's not that the scientific facts were wrong. No, it's not that the scientific facts were wrong. The fact is that I, myself, have ruined Ag Science Month, something I have been planning and preparing my entire career. Professor Jones is going to be so disappointed in me for ruining it. Is that camera still on?
Oh, well, we'll take a break from Rob as he regains his composure there.
I do have a favourite breed of cow though. The Highland cows are my favourite breeds of cow.
Yeah, the fluffy ones that you showed me.
Yeah, they love getting their hair brushed and stuff. Very cute. Cute.
Do they love? Have you asked them if they like getting their hair brushed?
Have you seen the videos of them getting their hair brushed? They're having a great time. It's like a good back scratch. They love it.
Oh, back scratcher!
Back scratcher!
Back scratcher!
Oh, Aoife's got a good joke there. You'll like it.
Oh yeah. Okay, cool. Aoife's joke. Here we go. When we're having issues with turbulent flow, we put a young sheep in it, then we have laminar flow. Bit of fluid dynamics coming today on a Saturday morning from Aoife. I love it.
Yeah. Oh, Sophia likes yaks.
What kind of noise does a yak make? And he's afraid of cows, really.
There is a video of me being chased by a herd of cows.
Oh yeah?
When we were camping one year. Probably roughly on a July 19th, I would say. Oh, really? Getting chased by a herd of cows, yeah. So I'm just wearing like a luminous yellow hoodie and just like running along in the distance, and then there's just a herd of cows following me. Pretty much, yeah.
So it is time for next week's challenge. So we did a lot on last week's challenge, and definitely try it. That's something that we really want you to try at home. It's super fun, really cool. But we have a challenge for you next week too.
For this week's challenge, you're going to need a glass bottle, maybe like a wine bottle or something. Might have some of them left over from Christmas, and a cork. So what you're going to do is you are going to jam the cork inside your wine bottle. So that's That ain't coming
That's
out.
inside. That's not coming out.
Okay.
How would one get that out?
Well, that is the challenge. So the challenge for you for next week is to be able to remove a cork from loose inside a glass bottle without smashing.
Oh.
You're loving smashing things
I know,
today. You
I'm
can't be doing that.
I'm out
so
of ideas
without smashing the bottle, you need to get the cork out.
Okay,
That's the challenge for
interesting.
next week.
That's your challenge for next week. So again, let us know if you try that challenge or last week's challenge
Yep.
as well, or any of the challenges that you've seen in Super Science Saturday.
Yes, there are many.
There are many at this stage. And yeah, let us know if there are any things you would like us to test
Yep.
on our Super Size pendulum drop.
Yeah,
would be
a
really,
tire
really
would be cool.
Tire would be really
We
cool.
get access to it. Maybe like a bike tire to start. 'Cause
You've
they're
got 4 in
lighter
your
than-
car. We'll just
You can't do that to Tracy.
we'll turn it into a tricycle. Like the Mr. Bean cars, just goes down, turns the corner, just falls over.
But then you might as well go the full way where he sits on the top with the broom and steers the car that way.
What an episode. What an
Who needs
episode.
to sit in the front seat of their car?
So, do let us know if you've tried any of these things, and we hope you have a lovely Saturday.
Yes.
Yeah. Yes.
Jeez.
Yes.
Have a nice week.
Yeah, have a great week. Thank you for joining us here for this smashing 18th episode.
Episode 18?
Yeah, so that's
Whoa.
what we wanted to make a big smash for the show to celebrate our 18th episode.
I think we succeeded.
we have succeeded. A smashing show. Thank you all for joining us. I hope you all have a lovely Saturday, and we will catch you all on the flip side.
Bye.
See ya.